The 2020 Solar Plus Storage Project of the Year, as voted on by the readers of Solar Builder, is the Amesbury Landfill Project in Amesbury, Massachusetts. Yes, battery storage on a landfill. At the time of its completion, it was the largest solar plus energy storage system in the state. Here to tell us more is Kevin Magaya, Vice President of Business Development with CS Energy, the project's developer and EPC. Thanks for joining me, Kevin, and congrats on winning the Solar Plus Storage Project of the Year for 2020.
Thanks for having me. Yeah, it was great, great news to get that we were awarded, and looking forward to telling you more about the project.
Yeah, so how did this project even come about in terms of adding storage onto a landfill?
So we have done about 30 landfills to date, solar installations on landfill. A few years back, we had built a landfill up the block from this project, and it was a successful landfill. It was owned in part by the city and Waste Management, so that was a great one to have in our background. The city came up with an RFP to basically take this unusable portion of land and try to put solar in it to generate revenue for the city. At the same time, the state came out with a new storage program, the SMART program, that required storage to be part of the project for anything that's above a half a meg. So here we were permitting a project, we were permitting on a landfill, kind of going through a typical process. The new regulations changed, and we had to figure out how to incorporate storage into the system. And it was great at first, like, hey, storage, we've done a few storage projects as well. But then we kind of had to take a step back and said, wait a minute, this is a landfill. It's a giant container full of batteries. The thing is pretty heavy. How do we actually, design this? And then how do we get the city as well as the DEP, the Mass DEP, comfortable that when we put this container on top of the landfill, it's not going to damage a landfill?
That was definitely my first question, was how you actually accomplish that, because it seemed like it was a new challenge for you to kind of figure it out. So so what was the solution?
The first thing we needed to do is understand exactly how heavy is it going to be, right? So this is kind of a very basic question, but what is the design of this container? Is all the weight on one side? Is it evenly spread throughout the container? So now you've got this giant rectangle that you are going to put on top of a landfill. And the key concept for solar installations on top of landfills is you've got a certain amount of pressure that you can put per square foot, so a PSI limit. So we have this threshold that we know we have to work towards or be below, which is like 7 pounds per square inch. We have that limitation. We know the landfill is not going to be damaged if we stay below that weight limitation. We've now figured out, all right, what's this container? All right, what's the technology? What does the layout look like? We're working with the battery integrators and the battery suppliers. And they're also, the challenge is it's all new for them too. So they're like, well, I don't know how it's going to be laid out. I don't know exactly how it's going to be loaded. So, work with their engineering teams to get that information. We figure out we have this giant box. It's going to be packed like this. It's going to weigh this much. All right, now we're going to put on the landfill. How do we actually spread that load out? So we do a lot of foundation designs and analysis to make sure that when we sit it on top of the landfill, it's not going to exceed that 7 pounds per square inch. There's a bunch of other things that went along with it. How do you access the container once you put it in the landfill? How do you make sure we have provisions for fire safety? A lot of different smaller nuances that we normally just deal with on the solar side that we now had to apply here.
So did that then affect anything about the actual solar design or site layout?
So the one thing that when you think about a landfill, there's a certain fixed space that you have that you can actually build in. So that's size for solar. Now we had to find a real estate for a container. The container has to have room around it. We built a pad up call it 3 feet in the air. So we had to be able to spread the weight over a greater distance. So we built this concrete pad, added stone underneath it, and the stone basically takes the weight from one fixed section and spreads it out over a wider footprint. So we end up losing solar capacity, but the gains with being able to sell, the power from energy storage outweighed what we lost in solar.
Were there any keys to any of the other equipment chosen on the site for this particular, for what you were doing? You get RBI racking, SunGrow inverters. Did those factor in for specific reasons?
So the racking, we chose the RBI system because the way the what are called purlins, so the metal structure that goes on top, they're connected from ballast to ballast. So the one thing about landfills, I would love to say the landfills are these beautiful caps that are nice and even, but landfills are 20, 30 years old. So as they settle and the material degrades underneath, you start getting all these crazy undulations, right? So it's almost like a crazy wave when you have your solar installation built. So you've got to select a racking system that allows you to kind of follow that grade. And the RBI system does a really good job of that because at every ballast, it's got a joint. So if you think like a door hinge, it kind of allows you to just transition into grade throughout the landfill. And then from an inverter standpoint, SunGrow was a nice inverter that, they're price competitive and they're the right size inverter where we can split up different sections of the landfill into a certain inverter. So as your landfill is now changing shape, your radiation, the irradiance from the sun is different. So the irradiance is only impacted to that inverter for a certain section. So you can kind of maximize your yield throughout the day by having smaller chunks of inverter sections on the landfill.
What's the outcome of the project in terms of benefit to the city? Do you have projections on lifetime revenue savings, or just what are the main benefits do you see?
The big thing is from looking at the solar plus the storage installation, I think it's about a little over 5 million kilowatt hours a year. The project is going to be providing. It's kind of green power to the city. The city is getting the benefit of the lease as well from the land. So those are the two major outcomes of, kind of why we tackle these projects. They provide green renewable energy to the grid. They help make diversify the grid, make the grid more sustainable.
Kevin, thanks for taking the time and talking with me about the project. And, just again, congratulations.
I appreciate the opportunity.